to 1855, one of the greatest mathematicians, Carl Friedrich Gauss, 1777 to 1855, one of the greatest mathematicians of all times, formulated the law expressing the relationship between the electric charge and electric field, which is called Gauss's law. The statement of the Gauss's law may be written as follows. The flux of the net electric field through the closed surface equals the net charge enclosed by the surface divided by epsilon naught. In symbols, closed integral of E ds equals to q upon epsilon naught. Let this be equation 1, where q is the net charge enclosed by the surface through which the flux is calculated. The electric field on the left-hand side of the equation 1 is the resultant electric field due to all charges existing in the space, whereas the charge appearing on the right-hand side includes all those which are inside the closed surface. However, historically, Coulomb's law was discovered before Gauss's law, and it is possible to derive Gauss's law from Coulomb's law. Proof of Gauss's law assuming Coulomb's law. Flux due to internal charge. Suppose a charge Q is placed at a point O inside a closed surface, as shown in the figure. Take a point P on the surface and consider a small area del S on the surface around P. Let OP equal to R. The electric field P due to the charge Q is E is equal to Q upon 4 pi epsilon naught R square along a line OP. Suppose this line OP makes an angle alpha with the outward normal to del S. The flux of the electric field through del S is del phi is equal to E dot del S, which is equal to E del S cos alpha, which is equal to Q upon 4 pi epsilon naught R square into del S cos alpha, which is equal to Q upon 4 pi epsilon naught into del omega. The flux through the entire surface is phi is equal to summation of Q upon 4 pi epsilon naught into del omega, which is equal to Q upon 4 pi epsilon naught summation of del omega. The sum over del omega is the total solid angle subtended by the closed surface at the internal point O, and hence is equal to 4 pi. Now we get the total flux of the electric field due to the internal charge Q through the closed surface is therefore phi is equal to Q upon 4 pi epsilon naught into 4 pi, which is equal to Q upon epsilon naught. Let this be equation 2. Flux due to an external charge. Now suppose a charge Q is placed at a point O outside the closed surface. The flux of the electric field due to Q through the small area del S is given by del phi, which is equal to Q upon 4 pi epsilon naught into del S cos alpha upon R square, which is equal to Q upon 4 pi epsilon naught into del omega. When we sum over all the small elements of the closed surface, we get summation of del omega is equal to 0. So we get phi is equal to 0. Let this be equation 3. Flux due to a combination of charges. Consider a general situation where the charges Q1, Q2 up to Qn are inside a closed surface and charges capital Q1, capital Q2 up to Qn are outside it. The resultant electric field at any point is E is equal to E1 plus E2 plus so on plus En plus E1 dash plus E2 dash plus so on plus En dash, where En and En dash are the fields due to small qn and capital Qn respectively. Thus the flux of the resultant electric field through the closed surface is phi is equal to closed integration of E dot ds, which is equal to closed integration of E1 dot ds plus closed integration of E2 dot ds plus so on plus closed integration of En dot ds plus closed integration of E1 dash dot ds plus closed integration of E2 dash dot ds plus so on plus closed integration of En dash dot ds. Let this be equation 4. According to equation 2, we get phi is equal to q1 upon epsilon naught plus q2 upon epsilon naught plus so on plus qn upon epsilon naught plus so on plus 0. Therefore, phi is equal to 1 upon epsilon naught summation of q or closed integration of E dot ds is equal to q upon epsilon naught. This is the complete derivation of Gauss's law.